Hi everyone, welcome back to day 12 of digital learning. We're going over unit 6, lesson 2.4 for math. At this point, I want to make sure that you already did the locating fractions greater than 1 worksheet. If you didn't, pause me now and do that. We'll be going over it tomorrow, but I want you to make sure that you please hold off on submitting your do now until you finish the entire lesson, including the worksheets that you have to do later on. I think a lot of the time I'm just getting the do now, but not the worksheets. So please hold off on submitting it until you're done with all of the work that you need. Now that you did the worksheet locating fractions greater than 1 on the number line, we're going to be going over our do now from yesterday, the lost spinner. So please get that out so we can go over it.
So this is our problem from yesterday. I want you to read it one time by yourself now to refresh what the problem is. So pause me and read through it. And so now we're going to read it again together and take notes as we go. So Tina has a problem. She wants to play one of her favorite games, but she lost the spinner. She remembered that half of the spinner was red. So half of the spinner was red. Half of the spinner red, and 1/3 of the spinner was blue. 1/3 spinner blue. Tina could not remember how large the remaining green section was. So we don't know how big the green section was. What should Tina's replacement spinner look like? So we're trying to figure out what Tina's replacement spinner looks like. What does the spinner look like? So I already know how much was red and how much was blue, but I'm trying to figure out how much was the green section. So what I'm going to do down here is draw a spinner. So I'm drawing a circle. And then I already know half of the spinner is red. So I'm just going to draw a line right down the middle. And I'm going to write half red. And then it says 1/3 of the spinner was blue. So I'm going to make 1/3, 1/3 blue. But now I don't know how much my green section is. So my green section is here. But I don't know how much it takes up. So I see that my green section kind of looks like it's almost half of my blue. So I'm just going to make this to show that it looks like it's half of my blue. Then I'm going to break up the rest of it too, because it looks like it's 1/3 of my red part too. If I had 1, 2, 3 green sections, that would show me one whole red section, or a half. Then I'm going to go right down. So I just split up my spinner into 1, 2, 3, 4, 5, 6 equal parts. And the reason that I did that is that I see that if I put 1, 2, 3 greens, it would fill up my red parts. And if I put 1, 2 green, it'd fill up my blue part. So if I just broke it up into 1, 2, 3, 4, 5, 6 parts, and this green part has 1/6. So what also I can notice is that 1/3 would be equal to 2/6. And that 1/2 is equal to 1, 2, 3/6. So this is what my spinner would look like, where half of it's red, a third of it's blue, and a sixth is green. Now it's asking you, what is the probability of landing on each of the colors on Tina's spinner? So red would be 1 out of 2 times. If I rolled something, I would get half of the times it'd be landing on red. If I rolled something again, it would be 1/3. For every 3 times, it would land on blue once. And then for green, it would be 1/6. For every 6 times, the probability would be that it would land on green 1 time. So if I was to roll something twice, it would probably end up on red 1/2 of the time. If I would roll something, it would end up on blue 1/3 of the time. And if I was to roll something again, it would end up on green 1/6 of the time. So it probably, since my green section is the smallest, it's going to land on green the least. It's going to land on red the most because it's the biggest. Another way to think of this is that I see that there's 1, 2, 3, 4, 5, 6 total parts of my spinner. And if 1/3 is equal to 2/6, then that would mean that 2 parts, and then 1/2 is equal to 3/6, plus 3 parts, and then my 1/6, which is only 1 part, should equal 6 total parts. So 2 plus 3 plus 1 equals 6 total parts, which is equal to 1 whole. So I could, right here, I could also do 6 over 1, which equals 6, because remember, a different way to show a whole number is by showing that number over 1, which will equal the same thing. These two numbers are the same.
We're going to be going over page 373 from yesterday. It was when we were comparing fractions to figure out which fraction is greater than, less than, or if they're equal to each other. So I'm going to read number 3 from yesterday. Jill drank 2/6 of a glass of milk. Jane drank 5/6 of a glass of milk. Who drank more? Or did they drink the same amount? Show how you know. So I'm going to write the rules of my problem. So Jill drank 2/6. Jane drank 5/6. So we're trying to figure out who drank more. So I'm going to make 2 fraction bars to show this. 1 fraction bar to show 2/6, and another fraction bar to show 5/6. Sorry, the mailman came, so my dog obviously had to alert us that there was a person in the driveway. So I made 2 fraction bars, one with 2/6 and one to show 5/6. So to make 2/6, I'm going to separate it into thirds to 3 equal parts, and then separate it each third into half. That way 2 are in each, because 2 times 3 is 6. So now I'm going to color in 2 parts, or shade in 2 parts. And for 5/6, I'm going to do the same thing where I separate it into 3 parts, and then in half. That way I make sure that they're all equal. I'm going to shade in
5 parts because it's 5, 6. So the question was, who drank more, who drank less, or are these fractions equal? So I'm just going to draw a line to show where this should be. So I see that 2/6 is less than 5/6, or I can say that 5/6 is greater than 2/6. So the question is, who drank more? So Jane drank more. And I can see that because there's a lot more filled in this hole than in this hole. I could also think of this on a number line. So if I was to make a number line, I would do 0 to 1 and also split it into thirds, then each third in half. 2/6 I would put in, so I have 1, 2, 3, 4, 5, 6 equal parts. So 2/6 I would put right here, and 5/6, 3, 4, 5. I would put right here, so I can even see right here that 5/6 is more than 2/6. So now I want us to think about the two numbers 6/8 and 5/8. Pause me now and think about which number is greater and figure out a way to prove that. So one way you could have figured this out is on a number line. And you could have done 8s by 0 to 1. You could have done 8s by putting a line in the middle to make it into 2 parts. And then another line to have 1, 2, 3, 4 parts. And then 4 times 2 is 8, so I'm going to separate it into 2 in each. So if I had 5/8, it would be 1, 2, 3, 4, 5/8, and 6/8 would be here. So I can see that 6/8 is greater than 5/8. Or I could have done the same thing with a fraction bar. So here we have is that 5/6 is greater than 2/6, and 6/8 is greater than 5/8. Is there anything about how we did this that was the same? Pause me now and think about how we compare these two sets of fractions. Both times we could have compared our fractions using fraction bars and a number line. Another thing that I'm noticing about these fractions is that 5/6 and 2/6 have the same denominator of 6. And 6/8 and 5/8 have the same denominator of 8. So one way that I could have done both of these sets, so this pair and this pair, is just by focusing on the numerator and seeing which number is bigger there. 6 is bigger than 5, just like 5 is bigger than 2. What do you think a rule is that we can figure out which is bigger when you compare two fractions that have the same denominators but different numerators? What is a rule that we can say? Pause me now and think about what can we say about that. One way you can think of this is that if my whole or brownie or fraction set is broken up into the same amount of pieces, like with the two denominators that are both in 6, or when it's both in 8s, I can just focus on the top number, my numerator, to decide which one is going to be bigger, because that means I have more parts of my whole. Remember what we did when we made a rule of when my numerator and denominator were the same. We made the rule when a numerator and denominator are the same, it equals one whole. So we made up a rule to show fractions that equal 1. Can we make a rule about comparing two fractions with the same denominator but a different numerator? So when it has the same bottom number but a different top number. Can we make a rule about what we can do when we compare fractions with the same bottom number but a different top number? So what I want you to do is in this assignment, comment a rule, just like we did with that. Comment a rule about how to compare fractions with the same denominator. What you should have done is made a comment on this assignment saying when I have two fractions that have the same denominator, what's a rule when I'm comparing them? So now I have a question, compare 2/4 and 6/8. Which statement is not true? So we need to figure out by comparing 2/4 and 6/8, which one is not true? Which one is not correct? Is 2/4 less than 6/8 not true? Is 6/8 less than 2/4 not true? Or is 6/8 is greater than 2/4 not true? So what I need to first do is compare using a fraction bar. So I'm going to make two fraction bars up here. So this one will be 2/4 and this will be 6/8. So 2/4 I'm going to put a line in half and break these up in half and shade in two parts. And then for 6/8 I'm going to do the same thing where I break it up into 4 parts first and then separate each part in half because 4 times 2 is 8 and shade in 6. So if I was to draw a line here and right down the middle, I see that 2/4 has less filled of my hole or shaded of my hole than 6/8. So if I looked at A, it says that 2/4 is less than, because my alligator's mouth is pointing to the greater fraction, so 2/4 is less than 6/8. I'm going to look over here. Is 2/4 less than 6/8? Think about that. Is 2/4 less than 6/8? It is. I have less filled here than here. So I know that one is true, but I'm looking for the statement that is not true. B says 6/8 is less than 2/4. So I'm going to look here. Is 6/8 less than 2/4? Pause me and think about that. I see that 6/8 has more than 2/4, so this one is not true. But I want to double check. I don't want to just circle something without looking at all of my options. So here I see 6/8 is greater than 2/4. 6/8 is greater than 2/4. I have more filled in here than here, so it is greater than. My alligator's mouth is facing to the fraction that is larger. So B is the answer because it's not true. Your have to today is to do quiz 2, which is in this assignment. Please take your time when you do every problem, writing down the rules and also showing your work when you are comparing your fractions. I don't want to get a paper turned in or a quiz turned in that doesn't show your work by using either fraction bars or number lines or drawing a picture. I need you to please be showing your work. If it's easier for you, please print it out or write it on a piece of paper and just number it. That way I can neatly see what answer is to what problem. So please check the next slide to see where your have to is because you have a couple activities that you need to make sure you finish up.